Hello, I'm Roman, and welcome back to the series of videos Neural Networks from Scratch in Golang, where we using this book called Neural Networks from Scratch in Python, but we writing everything with the Golang. And I wanted to remind that I've posted a video on the main channel why I'm switching more and more to use NeoVim. You will see the link right here, right now. Yeah, you can see that I'm using the NeoVim for this coding series, even that, yeah, I'm using it for this coding series, and I'm using the NeoVim more and more in various places. So it looks like I'm going to, well, I actually already moved to using NeoVim in all of the places where I could, except the part when I have to use Xcode. And I mean, I have a setup to do some macOS development with the NeoVim, but it's not suitable for my current project, the project that I'm working on right now. Anyway, in the previous video, I started to implement this accuracy kind of base class, but we don't have a base class because we don't have the virtual methods, or maybe I don't know how to organize it in a Golang. And you could tell me, I would appreciate it, because here it's written in a way there is a base class and there is self.compare, which is basically a virtual method. And in a Golang, I cannot implement a function for the interface. Like for example, in a Swift, you can create a protocol. It's called the protocol interface. I mean, that's basically the same thing. And then you can write an extension and you can write some logic based on the functions that are inside the interface. So for example, I thought at first that I will now declare self-compare as an interface function, as a requirement, that then I will write something like an extension for the interface, and I will just write this. It's not working. At least I didn't find a way to do this. So right now we have the accuracy interface and the calculate accuracy function that uses accuracy interface for the compare function, which returns, as you can see, the two-dimensional slice of the booleans, and then it counts how many true values are inside, and based on this calculate the accuracy. What it means, the next thing I need to implement is the accuracy regression, not this one. Regression accuracy, and I left this function not implemented on purpose. So for me, it's like right now it's very easy what I need to do. I have I implemented the initialization. So right now I need to implement this, but in Go. So we have the absolute value. Well, basically what we should do, we should go through all of the prediction values. I mean, I don't need to think if I'm going through the rows or the columns. Like, for example, I did for, where it was? I implemented something on the activation function. Here I will just, well, first I need to get the rows and calls number from the predictions. Why I need to do this? Because I need to allocate the result, which will at first result will be a slice of boolean by the number of the rows. And use predictions dim, will type int as the regression. Okay. Rows calls. Let's put it rows. And we return the result. But then what I need to do? I'm going through I mean, I will need an index, so we'll use I, and that will be the range of the result. Then I need to allocate another slice, but for the for the rows inside, and that will be the number of the calls. Then I need to go over over the slice, right? And what I need to do, I need to calculate the absolute value between the predictions and the target. This might mean, what is the regression? Calculate regression accuracy. Yeah, I mean, and in here, okay, assume predictions are one-dimensional arrays. Okay, so here I wrote in a way that it's one-dimensional array. This is why I'm taking the prediction raw data, and the length of this is the same, length of this array is the same of the target values. This is why it works. But in general, the dimensions of the predictions and the target should be the same. And actually, maybe I need to check this. What if predictions dim not equal to target dims, right? Then I'm just panic because, oh, why not to panic? I mean, I'm not implementing it as a library for somebody else. I'm implementing it for myself at this moment. So I can, no, I don't have to return some error or something like this. I can just panic as still I'm the only one who's using it. Teams are not the same. Multiple values. Okay, so I cannot compare. Oh, come on. Okay. Multi-valued value in a single value context. So really, I have to. Okay, do I have the calls? Okay, let's assume I ignore it for now. I have the calls and can I roll something like this? Expected, closed, found. I mean, the problem that it returns a tuple makes it really hard to use. Okay, return math rows, but math is it's inside row view, DAG view. Okay, so we have the result, and that should be math ABS, right? So we need to calculate difference between I and J minus target at I and J, right? And that should be less than precision. And that's it. Okay, we can set the accuracy object from within the set method in our object in our model class the same way as the loss and optimizer. So we going into the find, not it should be set, right? Okay, I will move it here. and do this. So then we have accuracy as the accuracy interface. And then we go into the set. Yeah, I'm always confused K and J. Accuracy interface, too many accuracy words. And then we have this, right? All right. Then we can finally add the loss and accuracy calculation to our model right after the completed forward pass code. Note that we also initialize the accuracy with the self.accuracy.init at the beginning of the train method, which can be called multiple times as noted earlier. In the case of the regression accuracy, this will invoke a persistent calculation a single time during the first call. The code of the train method will implement. Okay, we have the train, right? We have the train. So what do? We have the accuracy. We call the initialization method, and we take in y. Can choose y. Okay, so we initialized it. Then what we should do? So we have the output, and we need to calculate the data loss and the calculation. So the first is data loss, and data loss we should take from the loss function, right? And we will have x, no, have the output and the y. Yes, and this is my problem. Then I have the regularization loss and regularization loss, base loss. No. Bo, 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 bo. Uh, I'm a little bit lost. Okay, first, I think I need to remove the calculate method from the interface, right? Yeah, I needed to have some stuff to clean up. This we have, okay, and this and this, right? Then train. Okay, they don't have the calculate. No, it has the doesn't have the calculate. Okay, then it means I have the loss model calculate loss, and I will take loss function X, no, I'll take the output and Y. Okay, and then we will have, well, it has set layers, but it doesn't have the regularization, which is weird. Okay. Did I miss something? Okay, base loss. But what if I will add it to the interface right now? That should work, right? Train. Yes. Okay. It just comes from the... Wait, this is the thing I will fix shortly. Okay, we have the loss value, which is the data loss plus regularization loss. Okay, this is temp just to please the compiler. Met new dance and oh no, um, actually can do this row fix data to do fix target as I think. Um, 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 what is next? Then we need to calculate predictions, right? For the accuracy. So we have the output activation layer. It should have the predictions for the output, right? And then we want to calculate accuracy, which is accuracy dot, no, that should take from the accuracy with the compare. We call the out, no, we call the predictions. We call the predictions and we call y row matrix data. And again, this has to be fixed. Okay, finally, we'll add a call to the previously created member. We'll add a call to previously created method to remember trainable layers with loss object, which we'll call in the finalize method. Update loss object with trainable layers. I'm not sure I need to do this, but let's do this for now. Set layers, and we take in them layers. Model has trainable layers and right? Mm, Pass trainable layers, and then we go up and we do this. Okay. Okay, again, just to please the compiler. And loss value and accuracy. Why you cannot use it? Oh, okay. Here I actually implemented it already correctly. Can't use why. You can do this. Make not enough calls. Where main goal, main before, right? And then we need to the full model class so far. Okay, we have it different. We have this. Okay. Full code of the loss. Yeah, but I need to create the accuracy, right? But right now I have only one accuracy. Oh, no, oh, it's an activation. We have the regression accuracy, right? Okay, so then I need to have, what is it? Accuracy, and that will be accuracy dots regression accuracy. Then I don't need to call it, and then I just pass it. That's it, right? Yes. Now that we have done a full forward pass and have calculated loss and accuracy, we can begin the backward path. The backward path method in the model class is structurally similar to the forward path, just in reverse and using different parameters. Following the backward path in our previous training approach, we need to call the backward path of the loss object to create the inputs property. Next, we'll loop through all of the layers in reverse order, calling their backward methods with the inputs property for the next. Remember that we have set the loss object as the next layer in the last, no, in my case, it's a little bit different. Now we'll add a call backwards the train. Okay, so I'm going to the main, to the model. We have the train. I think I need to clean it up a little bit. So I have the train. I will put it here. Model as description. Okay. The description I will put here. So right now what we need to do, we need to create a backwards methods model backward that takes the inputs output. Okay. Output methods dance, right? So what we should take the loss and call the backwards, right? D values is the output, and yes, we need to have targets to calculate this. Target, which is again dense. And again, I'm doing this bad thing to do, fix target path. And then how can I create a reversed range? Do I have something reversed? No. Range. Maybe in the guides and iterators. Loop. Really? Okay. For wait. For okay, for statement. Range, okay. Reverse. The different function of ultimate because around different. K equal to range of m layers. Then I have I that is len of m layers minus 1 minus k. That will be my index. Okay, and then I'm taking the layers. Well, I'm taking the property layer and I'm calling the backward method, right? And what I should do, I should okay, and this is the difference. If I equal to len of m layers minus 1, which means that we're at the first one, then this should be different, because in that case we need to take data from the loss function. I mean that gets wait, loss interface. Gets the inputs. Oh, I didn't wait. Oh, I don't have it for the loss interface. Okay. Makes sense. Okay. Then get the inputs and target, right? Why too many? Oh, no. Right. But else, what do we do in else? We doing the same. We taking the current. We call the backward methods. But instead, we need to take values from the previous one. So that will be I plus 1, right? Right. And get the inputs. in the, yes, in the forward, that will be -1, so we'll go back 1. Here it will be +1, so we'll get, the next one. Okay, and then we need to perform the backward paths once we check all of the things. So that will be model backwards, right? And we take the output and we take the target. Okay, that's why. Okay. After this backward pass, the last action to perform is to optimize. We have previously been calling the optimizer objects update params method as many times as we had trainable layers. We have to make this code universal as well by looping through the list of the trainable layers and calling update params in the loop. So we have optimizer update reupdate optimizer post update, and right now I need to have to go over the layers. Okay. Currently the pre-update, it takes the layer, but I do have the trainable layers. So for, I don't need an index, a layer in, how I did this. I need to do something like this. So if it's the layer, if it's okay, then we call the optimizer to update the layer. Hopefully that will work. Then we can add useful information here. Here's where the last parameter to train method becomes handy. Print summary. Okay, I have it somewhere. Loss. Yes, this. If epoch divided by print every, but this time I will change it a little bit to be it in one line. So we have this loss. We have the data loss and regularization loss, right? Then I have the accuracy epoch. Accuracy and the learning rates. Here it will be not O, it will be M optimizer. A little bit long, but can I make it multi-line? What do you mean does the optimizer doesn't have the current? Really? Mm, see. Optimizer interface. Oh, really? For example, mm, mm, get current learning rates, right? Um, Model, where is it? Get current learning rate. Why? Optimizer in optimizer, where is it? Optimizer interface. Wait, what? Optimizer. Um, hmm, I don't need this anymore. Cannot. Simon said does not implement backwards. Mean squared error. Where is it? Mean squared. Uh, okay. Okay. One problem at a time. Okay. First, okay. We can now pass the accuracy class into the model object and test our performance. Make build have some okay model undefined model. It's undefined because it comes from the optimizer, and same here, optimizer. Okay, what else? Make no value used value. What? Get right. Well, 64 and which one I'm using the optimizer random. Okay. And this one, so I should have the return current learning rates, and that will get current learning rate. Can't use loss func as the loss interface. In the argument one will set loss mean squared doesn't implement loss. Okay, missing get the inputs. Okay, right. Func loss means squared error get the inputs. Math dance return loss the inputs. What else? What else? Missing get outputs. Get output outputs. Oops, forget. Out. Do I need the outputs? No, I don't need this. Loss interface. Don't need this one. Mean squared error as loss interface value in argument f. Loss mean squared error doesn't implement loss interface method backward has pointer receiver. So you mean it should be like this? Okay. Regularization loss has pointer receiver. Okay. And this, right? Okay. Unused right to fields. There's what does it mean? Loss layers. How it's unused right to field layer. Go unused. Interesting. I think, I mean, my main question, what it means. I mean, and this is what I don't know about the goal. Will I get the access to the data inside? I mean, will I get the access to the data inside it, or I will be writing in some sort of copy, and this will never be called. I think now next, well, I still have to do this one refactor loss function to take dense, yes, to work with the race of the target data. Yeah, I still have to do this before I can do something like this, because they instantiate the model, configure it, train, Our models behave well and now we're able to make new models. We have to continue to modify this class to handle for entirely new models. For example, haven't yet handled for the binary logic regression. This we need to add two things. We need to calculate the category accuracy. Yeah, so they are going to do some changes. Well, there is a validation, full train. Dropouts. I mean, there are actually a lot of things I still have to implement. I think I will spend a lot of time. Yeah, this is so we kind of will finish everything for all of the models that we produced before. And I believe kind of the long several hours of debugging kind of waited me right now. So yeah, I will stop for today. I will continue again tomorrow because yeah, I mean, I will need to fix this already so I can get rid of check how to write it, how the data is passed with pointer, no, without pointer receiver between interface and just struct. I mean, I need to start fixing these things before I will move forward. And I think, yeah, I will spend a lot of the time debugging it. But I think once, I mean, the problem with, all of the things, I'm thinking how I can cover all of the things with the tests, and probably I can cover all of the things separately. Yeah, the models right now is broken because I changed a lot of the things already, and I will need to tweak, recreate them once again. So I have the optimizer, utils, okay, layer, data sets with the mock data. Okay, this is the main classifier. I think I need to move it into the loss because the softmax loss, and I actually will need to change it too. Yeah, because right now it's kind of broken. Yeah, actually, sudo fix. Okay, remove classifier package, move into loss, and another thing is fix models. Okay, I still have a lot of to do, but that's good. Thank you for watching, and I see you tomorrow. Bye bye.